Hello everyone, welcome back to Brighter Brainz. So today let's discuss about a new topic in the mathematics of 10th standard. So before going into the video, just click the subscribe button, like and share this video. So today we'll discuss a topic that is pair of linear equations in two variables. Pair of linear equations in two variables. So first, let us discuss the introduction of this pair of linear equations of in two variables. Okay, so what does this chapter is all about? So pair of linear equations. Here we are going to discuss, or we are going to deal only with two linear equations which are having two variables. Two variables is nothing but commonly a linear equation will be like this: ax plus b equal to 0. So this type of linear equations you already seen in your 9th standard. So in your 9th standard you have studied about pair of linear equations in one variable. Okay, so here in the 10th standard the continuation of it is pair of linear equation in two variables. So this is the one variable. Here a and b are two real numbers and x is only the one variable. X is only a variable that you have studied in the 9th standard. But now we are going to discuss about the linear equation which is going to be in two variables. Okay, so here x is one variable and y is one variable. So these are two variables. Okay, and a, b and c, these three are three real numbers. Okay, those are some real numbers. So here in this way the x and y will be the solution of this linear equation. So whenever we substitute any value in place of x and y, the pair of values, so that those values are called as a solution of this pair of linear equation. Okay, so suppose this equation will always be a straight line. Okay, ax plus by plus c equal to 0. Okay, and also here we are going to deal the graphs of these equations also. So let me say you clearly now. First, pair of linear equations. Let us write two pair of linear equation. Let it be ax1 plus by1 plus c is equal to 0. Be the one of the pair of linear equation, and the other one will be ax2 plus by2 plus c is equal to 0. Okay, oh sorry, it will be as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So these are two pair of linear equations which are having two different variables. Okay, these are not same variables, two different variables. So here x comma y, this ordered pair or else this pair of two variables are known as a solution of the linear equation. What does it call us? Solution of the linear equation. Okay, so here in this chapter we are going to discuss about the system of linear equations and the solution of a system of linear equations and some of the graphical methods and algebraic methods, and also in the end of the chapter we will be discussing some of the applications and what is the use of these linear equations. So we are going to deal with those also. So in the first exercise we are going to cover the system of pair of linear equations, that is the nature of these linear equations. Like if there is let us take this as example. Okay, a1x plus b1y plus c1 equal to 0 will be a linear equation. So we need to know these are two pair of linear equations. So from this we need to know the nature of the pair of linear equations, like in such a way that how many number of solutions, whether these two equations are going to be, and next what are the nature, whether it is intersecting or else coincident or else parallel lines. So in this way we are going to discuss a system of pair of linear equations. So first, this is all about the introduction, you don't need much deeper here. So now let us go into the system of linear equations. So there will be a table column in your textbook, so let us discuss that now, and this is the important thing which you need to know here. Okay, so first, um, draw a table. So first here, a1x plus b1y, let us write pair of linear equation. a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Here a1 b1 c1 are the coefficients, a2 b2 c2 a2 b2 are the coefficient and c2 is constant. Here a1 b1 are coefficients and c1 is constant, and x and y are two different variables, and these x comma y is a solution. Done? Are you clear? So now let us draw a table now, that is draw this table. If so, make few columns, let us name it a serial number, and here ratio, and next here graphical representation, and here is algebraic interpretation. Okay, so algebraic interpretation. So make a 4 columns, one is serial number, one is ratio, graphical representation, and algebraic representation. So first ratio, let us take it as a1, this is a ratio of the coefficients. Okay, ratio of the coefficients, a1 by a2 is not equal to b1 by b2, this is one of the case, and another case is a1 by b1 is equal to b1 by b2, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Next, third one is a1 by a2 is equal to b1 by b2, and which is not equal to c1 by c2. So first, these are 3 cases. Okay, here this is the ratio of the coefficients, that is coefficient of first equation by coefficient of second equation. Okay, a1 by a2 is not equal to b1 by b2, these are the values. Okay, these are not variable. So first is, if these two ratios are not equal, if a1 by a2 is not equal to b1 by b2, then here graphically these are intersecting lines. So the pair of linear equations will be the intersecting lines, and algebraic interpretation, the number of solutions will be exactly one solution. We are going to get only one solution for this. Okay, and next, if all 3 ratios are equal, if coefficients and constant all are equal, then it will be the coincident lines. So graphically those will be coincident lines, and next these will be having infinitely many solutions. So infinitely many solutions. Okay, so if there is one solution, ఏదైనా ఒక్కటి ఉంటే, ఏదైనా if anything is one, so it will be called it as unique, is it? So we can name it as unique also, unique solution. So sometimes in your textbook they will be using like unique also in some time. Okay, so it can call it as exactly one solution or else unique solution. Okay, here this is having infinitely many solutions, and if coefficients are equal, but if the ratio of coefficients are equal, but it is not equal to ratio of constant, so what it happens now? So graphically these are parallel lines, okay, these will be parallel lines, and there will be no solution for this type of pair of linear equations, okay. For this type of pair of linear equations there will be no solution. So these are the three cases, these are very important that you must learn until you appear your exams, okay. If two if the ratio of both the coefficients are not equal, those will be intersecting lines. Intersecting lines will is now nothing but like this. In this way two lines will be intersecting at a single point. So if there is an intersection point, there will be no multiple intersection points, there will be only one intersection point. So this intersection point will be having only one solution, okay. ఇక్కడ one solution అని ఎందుకు ఇస్తున్నారు చెప్పండి? Because when two lines are getting intersected, only those will be intersected at only a single point. So for that reason we are having only one solution, that is unique solution. Here a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Those will be coincident lines. So coincident lines will is nothing but they will be moving in in the same path. If it is one linear equation and if this is another linear equation, these will be moving in the same path. So that's why they will be having many solutions, because they are having many intersection points, okay. Next, parallel lines. So do parallel lines meet at a point? No, right? If this is one of the linear equation and the other linear equation will be in this way, if two straight lines are moving like this, is there any intersection point here? No. So if for that reason we are not having a single solution also. So there is no solution for this case, okay. Parallel lines, there will be no intersecting point, so that no solution. Coincident lines, there will be on the same line, so they are having many solutions. And intersecting lines, they will be intersecting only at a single point, so that's why we are having only one solution. That's all. There is nothing more to learn deeper here, okay.